Ahoy, mateys! 6.4 is about writing equations with two variables, both an x and a y. So let's jump into it. Here we go. So an equation in two variables represents two quantities that change in relationship to one another. A solution of an equation in two variables is an ordered pair that makes the equation true. So like if we had a graph with an x and y value, that's an ordered pair. And so any ordered pair that makes the thing true is a solution. Let's do an example of that, shall we? Also, if you're a note taker, which you should be, this is a great thing to add to your notes. Okay, so here we go, our first example. So is 3, 6 a solution to this equation, y equals 2 times x? So remember, this first value here is our x value. Our second value here is our y value. So let's go through this one together, and then you're going to answer B. All right, so the way you check that is you're going to replace x here with 3, replace y here with 6, and see if it's true. So when you substitute, 2 times 3 is indeed 6. Hey, it works. Therefore, it is a solution. So 3, 6, when you plug in 3 for x, you get 6 for y. It works. It's true. It's a solution. Okay, so now for B, is 4, 12 a solution to y equals 4x minus 3? Well, let's see. So the way you figure it out is you plug in 4 for x and you plug in 12 for y and see if it's true. So 4 times 4 is 16. 16 minus 3 is 13, which is not 12. Therefore, it is not a solution. 412 is not a solution to y equals 4x minus 3. Okay, look that over. These might be good examples to add to your notes. And then let's move on to the next part. So you'll have some on big ideas where you're going to have to determine if they're solutions or not. You do that by plugging in the values and seeing if they work. Okay, so now for this one, we have to talk about independent and dependent variables. So your x variable is your independent variable, the one that goes along the horizontal axis if you graph it. And then the y value is your dependent. It's the one that depends on the other one. So again, the x variable is your independent, the y variable is your dependent. This is another great thing to add to notes. And now let's move on to the next example. Gotta sneeze. There it goes. All right, so the equation y equals 64 minus 8x represents the amount y in fluid ounces of chemical remaining in a flask after you pour x cups. So what is the independent variable? What is the independent variable? So yeah, the independent, that's your x value, is the number of cups. And then the dependent is the fluid ounces. It's the amount of chemical remaining. Okay, so then the second part of this is how much chemical remains after you pour 5 cups. So when x is 5, what is y? How much remains? So to solve that, you're going to replace x with 5. So you're going to do 64 minus 8 times 5. 8 times 5 is 40. 64 minus 40 is 24. Therefore, there's 24 fluid ounces remaining. Okay, look this over. Make sure it all makes sense. If you have any questions, make sure to ask me in class. Now we're going to move on to our next example, which is how to graph. So to graph these things, one way to do this, which I believe is the way we're going to talk about here, is to make a table. So our independent variable, that's our x value. What you're going to do is basically just pick different values of x. It's good to start with 0 and then just do like 1, 2, 3, 4, and so on. And then you're going to replace that x with these numbers and get the y value. So when x is 0, you do 2 times 0 plus 1 is 1. So the y value would be 1. And then the pair that corresponds to is 0, 1. So when x is 0, y is 1. And then when you plug in 1, you do 2 times 1 plus 1. That's 3. So when x is 1, y is 3. That corresponds to 1, 3. Okay, when you plug in 2 for x, what do you get for y? Okay, when you plug in 2, 2 times 2 plus 1 is 5. So you get the point 2, 5. And then when you plug in 3 for x, what is y? So 2 times 3 is 6, plus 1 is 7. So when you plug in 3 for x, you get 7 for y. So that point is 3, 7. Once you have your ordered pairs, you then get a piece of graph paper, and then you put those points on a graph paper. So 0, 1, you go up 1, boom, there's a dot. 1, 3, you go over 1 and up 3. For 2, 5, you go over 2 and up 5. 3, 7, you go over 3 and up 7. You get those points there. Now, we've graphed before. If you have any questions about graphing, make sure to ask. If that's not review, if you just came here and you'd never graphed before, make sure to ask for help if you need it. And then you get a ruler, by the way, and you connect those dots with a ruler. Boom, and there's our graph. Fantastic. Look that over. Maybe add that to your notes. This is a great thing to add to your notes about how to graph. These are called linear equations. Okay. So now we have an athlete that burns 200 calories weightlifting. The athlete then works out on an elliptical trainer and burns an additional 10 calories for every minute. So what's an equation to represent the total amount of calories that they've burned? Okay, in this case, they burned 200. So you would, oh, they're spelling out how we get here. It's not clicking, but it's all going to, there we go. Okay. So they start off burning 200 calories to begin with, and then they're burning an additional 10 calories per minute times the number of minutes. Now we can use X or T or M or whatever letter we want to represent the number of minutes, but we need some sort of variable to represent the number of minutes because it can vary, it can change. So our equation would be the number of calories equals 200 from the weightlifting plus 10 times M. Okay, and then if we need to graph this, we would then pick different values for M. Again, I'd start with 0, 1, 2, and so on. They're deciding, let's go with 10 and 20 and 30. So after 10 minutes, based on this equation, how many calories total were burned in 10 minutes? Okay, to figure that out, you do 10 times 10 is 100, plus the 200 from the weightlifting is a total of 300. Okay, after 20 minutes of working out, how many calories were burned? Okay, so it's 10 per minute on the treadmill times 20, or on the elliptical times 20 minutes, plus 200 is 400. And then for 30 minutes, you would do the same thing. You do 10 times 30 plus 200, and it would give us 500 calories total. So if we wanted to graph it, we would put these points on a graph, connect them with a straight line, which we would do on Big Ideas. And if you have any questions on graphing on Big Ideas, let me know as you're working through them. Okay, and then let's see. Also, some of the problems are going to use this formula, D equals R times T. You may have learned this in science. So the distance traveled equals the rate, like the speed you go, times T, times the amount of time you've traveled. So that equation is used frequently. This is another great one to add to your notes. And let's quickly go through an example of how you use this formula. So we have a train that's going 40 miles per hour between two cities. Write and graph an equation that represents the relationship between the time and the distance traveled, and then how long does it take to travel 220 miles? So in this case, your rate, R, is 40. So you could say that D equals 40T. So that is your equation right there. Okay, so now see if you can figure out how long would it take to travel 220 miles if you're going 40 miles per hour. Okay, so to solve that without a graph, you would just do 220 divided by 40. This one wants to get us from a graph. So the way you could graph it is in 1 hour, it goes 40 miles, 2 hours is 80 miles, 3 hours, 120 miles, 4 hours, 160 miles. You would then graph it. Bam! Look at that, lovely. You'd then use a ruler to connect the dots. And then you could use this graph to figure out how long it goes 220 miles. You find 220 on the graph. Well, there's 240, there's 200. 220 would be right here, and you go over and it looks like it's going to be about 5.5 hours, which you could also get by just dividing 220 by 40. There we go, 5.5 hours. Okay, so that's about as difficult as the problems you're going to see. And if you have any questions while you're working on these on Big Ideas, let me know. Good luck. I will see you in class.